You know what? I'll take one. Black.
Awesome. Yeah. Hey everybody, welcome to OWASP Atlanta. I am here with all of our leads today. Alif, Thomas, Guled. Welcome to all that are in the room. Thanks to Victoria for hooking us up with a stellar location. Honestly, this is right now probably my favorite location so far. And it's not just because of the food outside, that is contributing to the happiness factor. Today, we are joined by Tim Erlin. Tim has been a veteran in the space of AppSec for quite some time. He is a VP of Product Security at Wallarm. If you're not familiar with Wallarm, they're known for API security. Today, we'll get into that in a minute. Let me follow the schedule of the OWASP intro here. For those of you who are not familiar with OWASP, we are a nonprofit international organization. 30,000 plus global members. There's chapters all over the world. I've been affiliated with OWASP for almost 20 years. I've run the chapter, I don't know since even when, maybe since 2009. Guled joined. Guled has been amazing. Alif has been amazing. Thomas has been amazing. I've actually been the slacker. So we have a great chapter in Atlanta. It's actually been one of the more notable chapters over the past 20 years for OWASP. It's an international, so OWASP stands for Open Web Application Security Project. Actually, Open Worldwide Application Security Project, technically speaking, because they just changed the inclusivity of other things beyond web. But it's a great effort to be a part of, and we welcome those that are here and also that are remote. If you do want to support us, please do consider supporting OWASP. The financial contributions you can do through OWASP.org. You can select the OWASP chapter, and what this does is it helps to fund events that we put on together. Like we have a phenomenal holiday party that we're gearing up for. Last year was a great success. We've never had a holiday party like the one that was largely championed and organized by Alif, one of our leads here at the OWASP Atlanta chapter. This year, it's going to be at the Neighbors Pub in Virginia Highlands, a great spot. A lot of fun things. So it's a great place to network with the AppSec, InfoSec, cybersecurity community here in Atlanta. And so 7 p.m. So mark your calendars, Wednesday, December 10th. And if you're also interested in partaking in OWASP Atlanta and being much like Tim, who's our beloved speaker for this month, please reach out to us. We have a Slack channel. I think there's a Discord channel that Guled is very active on, but you can also reach us on, if you just go to OWASP.org, you can find our contact information under the Atlanta chapter. So let's move on to today's, sorry.
Okay, Renee.
Okay, so introducing Tim Erlin. Tim, again, is VP of Product Security, correct? VP of Product at Wallarm. I've known Wallarm in space for quite some time. They're known for being great players in API security. I think the topic today is extremely interesting because they're looking, as mentioned in the kind of like the overview of today's talk, it's going beyond the top 10 taxonomies that are out there and really looking at something that's more agnostic to technology and looking at business logic of use cases in terms of a top 10. So with that, Tim, I'll put it to you.
All right. Get my slides up here. Okay, we're good. All right, so thank you for the introduction. As Tony said, I'm Tim Erlin. I'm the VP of Product at Wallarm. Why am I here talking about business logic abuse? I thought that's a good starting point. So back in June, OWASP published a new top 10 for business logic abuse. 2 of the 3 leaders on that project are from Wallarm, our founder and CEO, and one of our lead product managers. So that's why I'm here talking about it. Just to provide that little bit of introduction, we can start with a little bit of a discussion about what a business logic attack is. Why are we talking about this? And I actually want to set a little bit of context. So first of all, as Tony said, Wallarm is an API security company, so my examples tend to be API centric. But it's important that for this topic, they don't have to be. So while I may use examples, I'll try and also come up with examples that aren't API centric to make it a little broader. So I want to set a little bit of context between these two broad categories of attacks, stateless attacks and stateful attacks, which will come up and be useful later in the presentation. So for a stateless attack, we're talking about an attack that doesn't require that you maintain states. The example I have up here is like SQL injection. It's a reasonable example because it applies to web applications. It also, thank you, it's beautiful. It also applies.
We're getting, we'll let the audience work.
I will pause.
Everyone is unmuted.
Testing. Anyone online? Oh, yeah. Can you hear me?
Okay, yes.
Okay, cool. So as I was saying, a stateless attack doesn't require more than one interaction. So SQL injection is a good example. You can use others like, you know, a path traversal attack or remote code execution. The point is that the attacker sends one request, they get a response back. Either the attack succeeded or it's not. So in this case, they either get the data back that they're looking for or they don't. When I talk about a stateful attack, it's one that requires that you maintain state across multiple requests. So it's more behavior based. Each individual request by itself isn't necessarily an attack, might not be recognized as an attack, but the collection of them together, that behavior indicates that there's a malicious activity going on. So in this example, you've just got sort of iterating through IDs, starting with 1,000, you get a 404, 1,001, you get a 404, 1,002, oh, you get a 200. Now you've got 200s as you iterate through that. That might look like a OWA attack if you're familiar with the OWASP API top 10, broken object level authorization. So trying different objects until you get one that succeeds. So that's kind of a useful foundation for talking about business logic attacks or business logic abuse as a whole. So if we move forward to kind of the definition, what's the difference here between other types of flaws and business logic? Well, we want to draw this distinction. There are flaws in code. So these would be errors in the actual programming that's involved or in the libraries that are used where the root cause is an issue, a mistake that a developer has made somewhere along the way. And examples like that, SQL injection, as we talked about, cross-site scripting, anything buffer overflows, memory corruption, that kind of stuff falls in that category. We're all very familiar with those types of things because they're pervasive across the space. When we talk about business logic attacks, we're talking about something that isn't necessarily a flaw in the code. The application itself is functioning as it was designed to function, as it was built to function, but that design enables abuse. So examples here, redeeming a coupon that should be a one-time coupon multiple times. In this case, the application is doing what it was designed to do, what it was built to do, but there's a flaw in how it's enforcing the intended business logic. I always like the example of skipping steps in a multi-step workflow. The easy example that everybody can understand is skipping a payment step in a purchasing flow. So, I put something in the cart, I should pay for it and then go to shipping, but if I can skip that payment step and just have it shipped to me automatically, that's skipping a step in that workflow. So those are examples of business logic attack. In this case, that root cause that we're talking about isn't that the developer made a mistake in the code somewhere, but that there's either missing or flawed enforcement of some set of business rules involved. That makes sense. And I should say, I'm happy to answer questions or have a conversation. This is not a huge room, so feel free to interrupt me, ask questions along the way if you like. We can always have a conversation as much as me talking. So how common are business logic attacks? Why are we talking about this? There's some data here from Wallarm's Q3 API threat stats report, which hasn't been published yet. It should be published next week if we can manage to keep it on schedule. But we do these quarterly API threat stats reports. And as I was putting that report together, there were a couple of data points that I thought were interesting. So the first is comparing the rate of increase, the percentage increase in API vulnerabilities from Q2 to Q3 compared to business logic incidents or public breaches that occur where business logic was a root cause, would be a more accurate way to put that. So what we saw is that API vulnerabilities were increasing at sort of this 20% rate, but that the number of incidents or the percentage of incidents in which business logic attacks were a root cause or a key factor was increasing at a faster rate between those four. So it just tells us that in that sort of comparison, the presence of business logic abuse as part of an incident is moving at a faster rate than API vulnerabilities as a whole. I also pulled some data from the Postman 2025 State of the API report, which was published recently. In this report, what I like about that report is they keep asking the same questions every year, and so you can look at trend data, just as a side note. But in this case, they asked about organizations that identify as API first. And if you put those two, we are entirely API first, or we are somewhat API first. If you put those two metrics together, you end up with 82%, which is a lot. So most organizations in some capacity identify themselves as an API first. Why is that relevant to business logic abuse? Because the broader the attack surface of APIs, the broader the attack surface for business logic abuse as a whole. APIs as a programmatic interface tend to enable more opportunity for business logic abuse or business logic attacks in a highly scalable way from attackers. You don't have to emulate a browser and interact with a web app. You can connect directly to those APIs. And then the last data point is looking at the breaches, the API-related breaches that we cataloged in Q3, and looking at which of them, what percentage of them included some kind of business logic abuse. And so it just shows you that there's a high percentage, not a majority, 39% if you want to round up a little bit, of them included some kind of business logic abuse, which is an interesting piece. So business logic abuse isn't the top of the, it isn't the majority, but it is kind of the tip of the spear, and it's growing in terms of its frequency, in terms of what we see in the data. So that's part of why we wanted to talk about it here. To turn a little bit to OWASP, I like looking at sort of the universe of OWASP top 10 lists as part of the reason that we wanted to do this business logic abuse top 10 list.
You're gonna have to take this from you.
You can,
Ready to.
you can have it. It is not a Wallarm branded image.
That's it.
So a lot of these lists are very technology centric. Not 100% of them, but you start looking through here and you go, oh yeah, okay, so you've got MCP, you've got Docker, you've got an OT list, client-side security, you've got LLMs, you've got cloud native AppSec. You of course have the original OWASP top 10 list for web applications. So they're very technology centric. And as we looked at that sort of universe of top 10 lists, the two Wallarm folks who sort of started this project said, there's something missing here. We see that in each of these individual top 10 lists, there's some limited coverage of a business logic attack here and there. But as a separate concept, it's not really covered. And business logic abuse as a concept is technology agnostic. It doesn't really live in a specific technology. So you could talk about a business logic abuse attack against an API, you could talk about it against a web application, you could talk about it against a thick client, which hardly exists anymore. So it's worthwhile for us to look at, can we build a top 10 list that really is technology agnostic and gives us the ability to describe in a systematic way these types of business logic abuse. And then the growth in AI and agentic AI brings in an interesting factor as well, because we're existing in this moment of technology change. And while we as a company would love to argue that AI security really is just API security because it's all built on top of APIs anyway, there's another sort of counter argument which I find interesting, which is that AI applications are primarily a distillation of business logic, because you've taken out a lot of the mechanics involved in interacting with them, and you boiled it down to business logic. So if you want to exploit a generative AI application, you are employing a lot of logic abuse to do so through text, often through a prompt, which is an interesting perspective to take on it. So from that perspective, we thought it's time to focus developers on how do they deal with and build to prevent business logic issues, and it's time to focus security on how do we identify and defend against these issues. And so that's kind of where the top 10 list came from. So let's take a look at the top 10 list itself. Before we do that, a little bit about the methodology. Now there's more detail on the methodology that was employed on the OWASP page itself. So if you want to read a bit more detail, you can do that. And if you really want to dive into it, I encourage you to reach out to the primary contributors who would be happy to talk about it, for sure. But we wanted it to be grounded in both theory and data. So the team of three in this case, started by taking a Turing machine model and building out the ability to represent any set of business rules in a common way, in a structured way, so that they could represent them in a taxonomy. And then they took that taxonomy and they compared it to real data. So there's some information up there about CVEs and GitHub issues to make sure that what they had described in that Turing model actually applies to real data if you compare it to real world data. And then they spent some time focusing the scope, making sure that they weren't covering things that were covered in OWASP top 10 lists that already existed. And then there was some process of iterative refinement that occurred both up until the point of the initial publication in June of this year. And then there has been actually a second version that was published with some additional refinement. So that was kind of a high level methodology. And as you all know, OWASP's sort of philosophy is about community involvement and community contribution. So there's no expectation that this top 10 list is a static thing that is now done and nobody else should contribute to it. So if you think this is interesting, or if you want to dive into more, I absolutely encourage you to try and get involved, reach out, because there's definitely more that we could do here if it's interesting to you. Okay, so top 10 list. This is the whole top 10 list. I'm not going to go through each one of them because that would take a long time and probably get boring by the time we get through the first 5. But I will highlight a few that I think are particularly interesting. And then we'll look at some real world examples. So let's start with the missing transition validation. You'll also notice one of the changes that was made in the second version was to rename them, aside from some recategorization, which was important and material to the list, rename them so that they can have some acronyms that we can use, which is potentially actually useful. So the missing transition validation, which is MTV. So this is a condition where you're calling later workflow steps directly because the app doesn't check that you needed to do something else first. So there's no validation of that transition state. So you can think about, and in fact, if you can think of one, tell me, because it makes it more interesting if it's interactive. Examples in applications like an API is a great example where you could call a function that's supposed to be behind authentication, but isn't authenticated. You've skipped a transition state of being authenticated. Or you could think of another example with an API where you've got a workflow and you're skipping a step, as I said. But I like to take this and say, how could we apply it to things that aren't APIs, things that aren't current technology? So, or things that are more current technology. You could think about a Gen AI example, perhaps, where you're getting it to take a step in a workflow with an AI agent without validating that you're allowed to do that somehow, things like that. So, yeah, I think that's an interesting example, one of the business logic examples. Another example is the artifact lifetime exploitation. So this one is using things that are short-lived or should be short-lived, things like tokens or sessions or temporary files after they should have been expired. And that would be where the application itself is not validating that expiration. So in this example, you could think of a authentication token that should be short-lived, that is, the API isn't checking that it's been expired and letting you continue using it or letting an attacker continue using it. I also like to take this example back to when, sort of before people were building APIs to web applications that would store temporary files and not clean them up very efficiently. And so if an attacker could get access to those temporary files or cause the application to keep using a file that should have been removed, there was some exploit surface there as well. So a good example of business logic abuse. And then the last example I'll pick out here is shadow function abuse. This is another one that's easy to sort of come up with examples of. Anytime there's a capability or a function that should have been removed or the developers thought was hidden, so it could be a test utility or it could be a deprecated API, that kind of thing, that falls into that shadow function abuse category. And this also works for modern examples with APIs where you have an API endpoint that should have been deprecated. And it also works for older examples with, web servers that have test utilities that should have been turned off. That function isn't meant to be there. It should have been turned off or hidden. Nobody did it. It's now a shadow function. So this is logical. So I'll flip back just briefly before we dive into the real world examples to the full list. Anybody have any questions, any thoughts, any examples that they came up with while I was talking there? No, at least pausing gives me a chance to take a sip of my drink.
I mean, I was thinking about on GitHub, how people will publish tokens on accident and then try to erase them, but you can find them.
Yeah.
Or if you publish a token on GitHub and thought you expired it and someone else gets their hands on it, that could be a like
Yeah. It could,
exploitation.
especially if you think about like a test token, like you created a token for a test scenario
Mhm.
that shouldn't continue working. It was temporary, but it continues working. That would fit very clearly into that example. Yeah.
Shadow function abuse. I've definitely seen organizations like spin up web endpoints to test things for development or for QA.
Yeah.
With all of the trace enabled and everything,
Yeah.
like completely publicly exposed.
Yep.
And then sometimes also forget about.
Yeah, a pen tester's dream, right?
Our OWASP mass talk, they went into depth on that as well.
Yeah, that's cool. Yeah, we were actually talking earlier about how, we sort of progressed through different versions of shadow capabilities that show up as a whole, like shadow IT, and now, shadow APIs, shadow AI is now a thing that's sort of developing too. So yeah, that's a great example.
I think that this is very helpful because oftentimes like traditional business logic abuse is so hard to test when you're doing manual pen testing. And I think that's why a lot of tools have a difficult time in emulating exactly how to do that.
Yeah.
Because the business rationale for how applications are doing different use cases are going to be constructed differently.
Yeah.
So you can't really use like a DAS tool out of the box. But I do see like some of the stuff, here, because I mean, business logic abuse as a term.
Yeah.
Has been around for quite some time.
Yeah.
Some of the stuff could be, considered like implementation, misconfiguration, things like that. Not necessarily when people think business logic, it's you have engineering building a functional use case on a design requirement, right?
Yeah.
But still think it's
Yeah. So
yeah.
I think there's definitely conversation worth having there. Again, we published the first version of this in June. There's been one more version since then. So we're still early in the life of this top 10 list. And the goal, part of the goal at least, is to give everyone, security folks, developers, a framework in which to have that conversation.
Yeah.
Is the application working as designed? Does it allow you to do something that you shouldn't be able to do? Does it fit into one of these categories? Can we talk about it? Is it a resource quota violation, or you've got a category for broken access control. Internal state disclosure is one where that conversation about, is it just misconfigured? But it's giving up information it shouldn't, and it was designed to do that. So I think it fits into business logic abuse, but totally cool conversation to have. I agree. Yeah. And the goal is that this list and these categories make their way into those internal conversations and let people communicate more effectively across sort of organizational boundaries, if you will. Yeah. Awesome. All right, so let's flip forward to a couple of real world examples. 4, if I remember correctly. So one thing I do want to say is that when I put up real world examples, my goal here is not to shame the companies that have had these incidents. I think everybody in this room knows that these incidents can occur for almost any company.
Except one, and they'll know when we see it, just the
You can point it out.
That one, yeah, and I think everyone will go, yep, I agree.
The goal is to actually learn from the incidents that have occurred so that we can improve what we're doing as a whole. So this example with Stripe is actually as most incidents, as is true for most incidents, there are multiple steps here. It's not just one thing. So this is an incident that occurred where there was essentially a malware campaign targeting a card skimming campaign. So there was malware involved. But what the attackers did that fit the business logic abuse category is, in order to make their card skimming operation more efficient and less likely to be detected, they wanted to validate that they were pulling valid card data only. And so they found a Stripe API, a deprecated API that they could use to validate card data before they exfiltrated it. So it reduced the amount of data they were exfiltrating, made sure that they were only getting valid cards, and it leveraged an API that Stripe had deprecated but not removed. And so that's the shadow function abuse. And so this, it was a longer campaign as these things go, but it was published in April of this year. So this is one of those examples of, business logic abuse showing up in a real world incident. So, any comments or thoughts or questions about that one?
That was really smart to do.
Yeah, I mean, if the attackers were stupid, they would get caught more often. And of course, we can only talk about the ones that did get caught, right?
We have biases here. We only care about the smart ones.
Yeah, there is.
If they were stupid, we wouldn't care.
Yeah, well, according to the lawyers, all of the attacks are sophisticated, so.
Also true.
Of course. Highly sophisticated, unavoidable.
Yeah, sophisticated and unavoidable, that's right, that's right. How many folks heard about the sales loft incident?
Yes.
One, two, okay, not as many. It's interesting to me because as a vendor in this space, I of course am paying attention to this, and it feels to me like it's all over the news. But it's not really in the end. So what occurred here is that you have a company called SalesLoft. They produced a product called Drift, which is an AI chat tool that connects to your Salesforce instance and trains itself on all your Salesforce data and gives you the ability to ask it questions about your Salesforce data. So it sits in front of a CRM, Salesforce, and lets you interact, with essentially an AI agent that knows. I don't know if it actually took action, so I don't know if it qualifies as an agent or not, but it has access to all that Salesforce data. And in a mechanism that has not yet been shared, either one or multiple authentication tokens, OAuth tokens, were stolen or compromised that the attackers then used to authenticate to those Salesforce instances. And the reason I caveat that is because there's some rumor and conversation about, is it that they stole multiple tokens, or is it that there was one token that was really improperly scoped and worked across multiple victims, if you will. But there were a ton of companies that were impacted here, not just Salesforce. I didn't list them up here, which is always challenging because then I have to remember them. And I only remember the cybersecurity vendors who were impacted. So it's Salesforce, Cloudflare, Zscaler, Palo Alto, and at least a dozen more. So big impact. And this one I categorize as artifact lifetime exploitation because those tokens should be short-lived. They should not live beyond the use of that integration. And if we knew more about the specific type of token that was compromised, we might categorize that further. But it fits into that category of, the application worked exactly how it was designed, but the attacker found a way to leverage that design to abuse it, essentially. So this one, I built this presentation before I started working on that Q3 API threat stats report. This actually I ended up labeling as the biggest breach of the quarter for Q3 because of that breadth of impact. Any thoughts on that one? Okay. Ticketmaster. Nobody really likes to think of Ticketmaster as a victim, but in this case, they are.
This is the one I was referring to.
Yeah.
Oh, poor ticket.
Right. There we go. That's what I was looking at.
So I labeled this as ongoing because it doesn't have a specific date, but basically there's this company, Key Investment Group, that is being sued now because of their attempts, successful attempts, many, to buy more tickets than they're allowed to buy so that they could resell them for a profit. And the reason I like this example is because it's not one type of attack. So it fits into that resource quota violation category, but they use multiple different methods to carry out, to try and achieve their objective. So the business logic abuse isn't it's not a specific attack, it's not a specific technology. It's a campaign, if you will, to you know, get more tickets than they're supposed to. Done. That's that one. Okay. And then the last one, which is my personal favorite in this example because, well, I'll explain why. So Restaurant Brands International owns Tim Hortons, Burger King, Popeyes, and Firehouse Subs. And they offer essentially a drive-through management system would be the best way to put it. And so there were some security researchers who found some very interesting opportunities in that drive-through management system. And they wrote a really great blog post about it, which was very quickly taken down with the DMCA request, and then removed from the Internet Archive. But I will tell you, because I read the original post, it was a fun post to read, actually. Yeah, I don't know, did you read it? No, it was fun, it was cool.
I can imagine.
For you know, if you're into this kind of thing, it was. So they started off by finding a sign-up endpoint API that anybody could sign up for. So there was no validation that you were actually a franchisee. And so you could just create yourself an account inside this drive-through management system. There was an email validation for it, but you know, it didn't really matter what the email was in the end. So that's that missing transition validation. And then once they were in, they actually found a GraphQL endpoint so GraphQL, if you don't know, GraphQL is a really cool API protocol, does lots of interesting stuff, but also provides some opportunities for attackers if you don't manage it correctly. One of those opportunities is that GraphQL supports these introspection queries. So you can query a GraphQL endpoint and it will give you back the schema of everything you can ask for in terms of data. Think about it like a database. Here's the schema, here's all the data you can ask for. So there was an there was a GraphQL endpoint with introspection enabled, which then gave them a bunch of information about what was behind there. They also found that they could sign up with that GraphQL endpoint without the email verification. So you could throw that in there as well. And then there was a plain text email in that sign up process with a plain text password. That was a problem. Ultimately, once they had that account, they got the global store directory. So now you've got this internal state disclosure problem. And then the one that I loved most in this story was this, in the GraphQL application, this create token mutation. So you could create a token that you could then go use for other services, authenticated, but there was no authentication to create the token. And so it's this funny, you know, cart before the horse problem. I don't know how to describe it, where I can't get into all these things I want to get into, but then there's this API over here that I can just use to create a token that I can then go use, and there's no authentication on that API. The end result that they end up with, kind of the end of the story, is that they got access to the audio recordings from people who were ordering at the drive-thru. And as a side note, which is not really a security flaw, just out of curiosity, all of those recordings, they feed into AI for analysis. And so there was some interesting anecdotal data about what they were actually analyzing, you know, the mood of the people ordering, how friendly were the people that were taking the order, this kind of stuff. I thought that was interesting. But they now had access to potentially sensitive data in those recordings. So interesting. Bunch of different issues in that report. Anyway, thoughts, comments about that one? Questions?
I have a lot of thoughts. They took it down. Did you ever find out why, or just
So
to protect the reputation?
yeah, RBI obviously requested that they take it down with a DMCA request. There are still news articles about it. So it's this, you have this sort of like meta situation where you can't read the original post, but you can read the posts about the post. Yeah.
Because probably, oh yeah.
But I also kind of find it interesting that they use DMCA to take down that article, because I'm just like, do you also use that against the business itself too?
You would think so, yeah. But it's a matter of who's willing to lawyer up, right?
Yeah.
As is often the case.
It sounds like the worst part is finding out that whenever you order something through a drive-through, it's being learned through AI without your consent.
Yeah.
Well,
And the second part is now, if it's published, then anyone can go and try and do this.
Yeah.
And maybe they were like, well, we need to fix it before you disclose it.
Yeah. I'm trying to remember if I don't want to quote incorrect data. I think that the researchers did say that they went through a responsible disclosure process or tried to, but I don't remember specifically, and it's possible they didn't.
Contracted to do with the fintech?
They were not, no, definitely not. Yeah. No, that would be a different story,
I was like.
which has also happened, of course.
Yeah, I was like, I don't understand, weren't they paid for their work? Like.
No, they're just doing it for,
Messing around.
yeah, for the lulz, I guess. But I
And a
mean,
lot of
you know,
people try new pranks or dry switches like that.
and there, you know, I mean, it's, there's also the bug bunny aspect of it, right? You'll find a flaw and then get them to pay you for it. Sometimes it backfires and they don't.
Yeah, this is a lot of loss.
Yeah, yeah. So. But you can find out who the researchers were if you want to dig into it further. You know, the articles written about it do point back to who those two security researchers were. And they've got other stuff they've done that's kind of interesting too. So.
Yeah, the best way for researchers really to get more exposure for what they've done is to not do responsible disclosure and go to a media outlet, and that'll magnify it, but
yeah,
they'll turn into the enemy of the company, and they'll maybe go into litigation. But if you do responsible disclosure, then no media outlet's interested because it's not first in news anymore.
Exactly.
So.
And it's a question of whether you're interested in exposure or you're interested in money, right?
Right.
You know, obviously.
In some cases you get neither.
In some cases you get neither, but publishing it without alerting the impacted organization first is gonna get you exposure, but nobody's gonna pay you for that, right?
So then you read the article, you got what they did into these steps, and then you associated it with all.
Yes, exactly.
Business logic.
They did not go through and associate it to the business logic
Yeah.
stuff that for me.
But it's interesting how many
Yeah, that's what jumped
different
out at me.
vulnerabilities there were.
Cause I actually put this deck together first, and then I was reading about this, and I'm like, oh, I have to add this example in because it's got multiple.
I guess the main difference between that capturing your content as you know, I guess your information as you're ordering things, that they don't know that that's taking place versus.
Yeah.
A mobile device, you know that it might be listening to you or to make your life easier, quote unquote, right? Or you can turn it off if you wanted to, but if you go to a drive-through, that there's no way for you to stop that from being collected, right?
There's no clear consent.
There's no consent, so it's a little bit, I know
Is
that.
consent I mean, we're now diverging off topic a little bit, which
Yeah,
is fine with me. Is consent required in that scenario? I mean,
At Chick-fil-A, yeah.
if you're ordering at a drive-through,
It would be. I would argue the side of in favor of the business of why could you not, as a customer that you're speaking to a microphone.
Yeah.
It's not like it's a big secret there's a microphone. They just happen to record it. That makes sense for quality purposes when they don't actually state it.
well, and yeah, you have to say that. If you're in public.
Right.
And you're being recorded, you don't have to give consent to be recorded.
That's the private business.
It's private property.
Any on private property. It's
But if you're on private property, I'm
But
thinking
is it-
you're outside, like, you could argue that
You're in public.
Yeah, but I mean, it is a private property and it is for a specific business transaction. So the expectation is that I'm gonna give you money for a sandwich, not that you're gonna record my call and analyze for quality assurance unless you tell me.
Yeah.
As is basically for all privacy complaints ever. As is basically the summary of all privacy complaints ever.
Well, I mean, most of it's found in like EULAs or TOSs and stuff like that, from a, technological standpoint. This is more human interaction, physical interaction, so it's a little bit, I think, more unprecedented. I'm sure a privacy lawyer would love to have a field day on that.
Probably. And the other question I would ask myself is the consent for being recorded, or is the consent for that recording being sent to AI for analysis, a third party, or do you need both, right?
Because some of the restaurants use third parties at the speaker.
That's
As
right.
you'll notice that the person's voice will change because the first inbound.
Yeah.
Is actually
There's a
some
recording, yeah.
call center somewhere else that's taking the first conversation.
Or a
Voice trigger.
Pre-recorded just to kind of facilitate things. I mean, the assumption is that they're gonna use the content to maybe sell you or send you an ad later about Burger King that just came out, do sandwich or whatever.
Or collecting data.
Or collecting data, but
How
that's the
popular
question.
Whopper is.
I just want a Whopper, bro.
It's like, give me some thoughts.
But, as we were saying earlier, what matters really is who's willing to lawyer up about it, right?
All of us.
I argue that people would just.
Class action, that'd be a class action. So, I don't like to complain about things without talking about what we can actually do about it. So, In terms of taking action, I think there are kind of three specific areas of action to consider. The first is around development, right? So if we're talking about business logic abuse, one of the purposes of having this top 10 list is to allow for better communication and training of the developers who are building these applications on what they should prevent from occurring in the application.
Sorry, we have a thought from online. So it says, in the state of Ohio, only one party is required to consent to record a phone call.
Yeah, that's right. There's one party or two parties.
State to state. Florida, you have that.
Every state has different privacy laws.
Yeah,
Every state's different.
that is a mess.
Okay, back to the.
State by state privacy law.
Everybody's just spying on each other in Ohio there.
GDPR for US is coming, and then I'm sure we won't be celebrating exactly, some people might, the lawyers will, for sure.
I thought all the lawyers were gonna be replaced by AI. I saw a chart and lawyers was like the #2 job to be replaced by AI, and I didn't believe it.
After therapist, something like that.
My biggest complaint with all of this is after all this data they've collected, all this training they've done, and my ads still aren't any good.
Your ads. I didn't hear that yet. My ads are your ads. Okay.
All right.
Give you
So, developers, right? Educating developers about business logic abuse issues is certainly one of the actions to take. And, you know, I actually, I did a talk about API security to a bunch of developers at one point, and the advice I got before that talk from the person who was organized was, whatever you do, don't talk about the OWASP API top 10. They are so tired of hearing about the OWASP API top 10 because everyone who comes to talk to them about API security talks about the OWASP API top 10. And I thought, that's perfect. That's fantastic. That's success. If the developers are tired of hearing about it, we have done the job of educating them about that top 10. So the same here, right? We can talk about business logic abuse. What I like about it is that it's not specific to the technology that they're working on. We can talk about these conditions that we're trying to prevent from happening in a way that applies to their work on that web application, that work on those APIs, their work with, you know, the AI agents that they're building. It's technology agnostic, so it has a longer lifespan. And ultimately, the goal is, of course, to architect applications that make these conditions impossible to exist, impossible to. But having said that, we're never going to be successful. We're never going to eliminate all of the business logic abuse conditions that might exist. So we have to talk about mitigation. We have to talk about detection and blocking, essentially. So that means that as security practitioners, it's up to you guys to ask the questions of the tools and vendors that you have. How do you handle business logic abuse? Can you scan for it, as you were talking about, for vulnerabilities that are business logic abuse conditions or business logic attack vulnerabilities? Can you detect and block those types of conditions in this, you know, security control that we're talking about deploying? You know, vendors, you have to ask those questions in different ways because vendors are going to say yes, unless you push them and actually say, well, listen, I've got this top 10 list. Tell me which of these you can actually detect and block or test for. And then don't expect that they can say yes to all of them. They'll want to, but it's a new list. If they pretend like in the next 6 months, if they say, I absolutely know about this top 10 list, I'd be skeptical because it hasn't existed that long. But it's a good conversation to have with the tool vendors that are in place. You know, my little pitch here is that detection isn't enough. Blocking is the requirement. You know, you have to be able to actually block business logic abuse attacks as well.
I imagine like with the drive-through example, like the first way in, what was that? The token, like that would be the.
Well, so the first way in was the sign up process that didn't have any validation that you were, you know, allowed to sign up.
So like the first mitigation would be like prevent.
Yeah, which is an interesting one because so that also occurred. I can't remember when, earlier this year, late last year with Dell. They had a partner program where, again, anybody could sign up. You didn't have to validate that you were actually a partner. And once you signed up, you could put in, you know, those Dell service tags. You could put in any Dell service tag and get information about the partners who service that, or information about the device. I can't remember which. And so the attackers signed up, and then they just, through that API, just slammed it with some absurdly large number of requests per minute that should have been detected. But the first step was, don't let people sign up who aren't partners. I'm not sure what tool you would turn to do that. It's a business process more than a tool. Right?
You
So,
have to know two people.
yeah, business launch, yeah.
One of the ways is that you just say you're not allowed to register unless your email address is from one of these
From
organizations.
a validated partner, yeah.
.edu for
That's
school.
business logic.
Yeah,
So
exactly.
I'd be interested if you go back to the drive-through example, if any of those could at least in theory be either tested for or you're blocked by automation.
Yeah.
My guess is none of those can be.
So again, I'll go back to my point that part of the reason to put this list together is because there's a gap today.
Agreed.
Right? So if you look at the open sign up endpoint, you could test for that as like a pen tester, you could test for it, right? By signing up with an email that isn't valid, isn't a valid franchisee, I should say, a valid email. In terms of an automated tool,
In terms of automated tool, they see an endpoint, they get a 200 back. It looks like a valid interaction. It is a valid interaction.
Yeah.
In technical terms, they're trying to test the logic behind it.
Yeah.
I don't think any of these you could test for.
Yeah.
You
could, well, I don't want to brainstorm it too far because it's a bit of a distraction, but I'm thinking about ways you could look for anomalies. From a detection standpoint, not a testing standpoint, you might find anomalies.
Okay, how about that?
Like the GraphQL, like the sign up bypass option that skips email. So with the introspection query, that you could detect for sure. Just a technical detection that, this was an introspection query, it shouldn't exist. The sign up bypass might see anomalies because nobody's using that to sign up. It depends on how the application is being used, right?
That's a normal part of the flow. You sign up for an account, right?
Right. Yeah. If that sign up workflow is being used regularly, but then it gets used in a different way, you could detect that as an anomaly potentially. But again, as with a lot of the business logic, it's specific to that application and how it's being used. Right?
Maybe not just sign up, having the exposure to the global store directory. I mean, that.
Yeah.
You could be limited to only whatever institution you're signing in as, not the entire.
Yes. But from a detection standpoint, if it's anomalous for someone to pull the whole store directory, you would see that as an anomaly. Like if the application workflow is, you're supposed to hit just one store at a time, or just the store that's yours, or the stores that are yours. Yeah. But it is, again, as I keep saying, the whole point is that because it's business logic, it's not an independently, atomically detectable condition. It's specific to the way the
It has to be
application.
detected with anomalies or a human test.
Yeah, exactly. Yeah. So it's a challenge, for sure. Which brings us actually to testing, so now we've covered it. This testing can go at the beginning and at the end. You could draw this as a circle. I didn't draw it as a circle, but good. The whole point is that having this top 10 list gives you the opportunity to talk about business logic conditions when you're talking about what are you testing for in either a pen test scenario or an automated pen test or whatever security testing tool you're looking at. You can have that conversation. Ideally, you can test for those things and you can feed those results to developers. I do think it's important to call out that testing is both pre-production and production, right? If you're only testing pre-production, you're not catching the things that are already deployed in production. But, yeah.
I do find it interesting that it starts with development, because I imagine that a lot of this will be in design.
Yeah, that's fair. You could actually split that into design and development.
Like if I tell my developers just make it do this, I don't also tell them, but also make sure it doesn't do this other thing. And it seems difficult because you can't qualify all of those things, but saying like, it is very important that people who should not be able to sign up. Like,
You're 100% pointing out my bias, which I tried to disclose at the beginning. My bias is towards API security. As a consequence, I squished design and development into one box, and I put mitigation and detection in the middle. But you're absolutely right. That's definitely true. Yeah. The other thing that I think is worth talking about around development, which came up in another conversation on this topic, is how the reason that attackers are better able to exploit business logic than developers are able to prevent it from happening is because the attackers tend to see the whole application or the whole system, and the developers tend to be silent. So as a developer, I have a responsibility to build an API that services this function. I build the API, it does the function. I run my unit tests, they succeed, great. It doesn't have SQL injection, it doesn't allow remote code execution, you can't do path reversal, fine, I've checked the boxes. But I've got 5 other teams that are building the other components of that application, and the business logic abuse occurs in the interaction between them. And there's nobody looking at the whole system as a whole, except that attacker. And that's the situation we often find ourselves in, I think.
But I mean, to your point on design, and I actually would say even goes before that, right? Because you build software based upon requirements, right? So if you've ever, and that's one of the challenges that most security people have, is that they don't have that full life cycle software development background. And when you don't have that, then you don't understand that you have definition requirements that actually give way to design, that give way to building out development requirements. You say that attackers have a better way of thinking things, but the security champion with doing threat modeling looks at definition and looks at design.
If you have that role and that person doing that job, yes.
Right.
Yeah. And the reason I said it's a trap there is because I think philosophically, at least, as a product manager, you shouldn't have to specify in a requirements document that the developers build the application securely. It should be part of the secure software development, the secure software, the SSDLC, right? Right. So if you're coming back to, hey, product manager, you need to tell me not to put in these vulnerabilities, I think there's a flaw there. But you clarified and said, no, actually, there's a role that should build that in at the pre-design stage as a standard. That makes much more sense. I agree.
Yeah, and I think there's other things that can enrich this framework, which is, again, like, let's take election software. Right, the elections are happening here in the state right now, until November's first week in November.
Yeah.
And some abuse cases that you think from a threat modeling perspective is that I want to be able to vote in multiple different districts, right? And so when you design software that is handling election software, then you factor that into the design of your product. So that's a lot more preemptive that goes way left.
Yeah.
Yeah.
Yeah, makes sense. Makes sense. So any other thoughts on this before I have 2 slides about Wallarm, but I don't want to dive into those unless we're done with the conversation here.
Any questions on mine?
Not so much a question, but more of a comment. Whenever I think of integrating some abuse cases, especially with developers, I always think about it from like that end-to-end integration tests. Like if we want to include a security requirement, including in the ways that developers work, which to me is like integration tests. You have to have a test for that. And by the time you get to the integration test, all the modules, all the things are included that you can fully replicate that. Of course, it's one of the most fragile tests, the integration tests, all the things they want. But I think it's like, sometimes I don't know if that's been like incorporated, if you've seen that in business.
It's interesting because it's also the integration testing is also usually towards the end. And so it's the thing where you're most likely to cause a delay. It's where where security runs into the requirements around velocity, right? Development velocity, which is, just friction. Yeah.
I do DevOps, and I argue consistently the exact opposite of so 2 theories, approaches I see here is you do a build, you do a process, and build your application. You run a security scan there, it takes an extra 10 minutes, 20 minutes to run. That's a delay of 20 minutes, and it sucks for the developer because it might fail and then they can't deploy their application.
Yeah.
On the other hand, you don't do that just so you can promote whatever you want to production. I'm going to give you a ticket for this. And then later on, when you get that ticket, it's a lot of work for the developer because it is from the same person. It's been there for a while, they have to go find it, to track it down. It takes them a lot more time than if you just did it up front. So I'm going to argue for the early failure and shift left a little bit.
Yeah, that's true. There was, I'm trying to remember the whole story, but I'll tell the part of the story and see if anybody else remembers it. There was a point where Microsoft put in place a policy where I think it was for security issues, where if an issue was found in a production product that had already been shipped, that it would go back to the developer who originally committed that code. And it was really painful when they did that because people had moved on to a completely different project. They would get pulled off that project, brought back to this thing they hadn't worked on in years and have to fix it. But the whole point was to emphasize that point, that you would rather have that failure now because it's going to take you less time than if somebody comes back a year later and says, actually stop what you're doing, come fix this thing that, was your fault from a year ago.
Yeah, and that's the pet peeve I have with I think we step in later in the game. The software development's life cycle been going on before the cybersecurity word existed, right? And now we want to come in and say, hey, you guys got to slow down. Like, wait, we got milestones. We got, you want to now start testing, and what are you testing? Do you even know what we're doing? Right? It's like that separation. I think that now with cybersecurity, we need to get involved at the planning stage and be part of their project plan. It should be a milestone, should be us. Okay, the security tests, the first phase. Did they do DAS? Did they do SAS? What was the end result? That should be part of it, but we're not. We come in like, we're looking in the glass and, we're not part of that, the development cycle at all.
Yeah.
Well, secure by design, that's the.
Yeah. I mean, that's certainly not a new or unique opinion, right? It's just hard to do and hard for organizations to implement.
I think it's changing now, definitely with AI. I mean, we're seeing it on the services side. Like a lot of companies are just sick and tired of traditional bolt-on security. They're done. I don't know if you saw the article out of Dubai where they got 30 grads from in Dubai. They said, let's try to recreate Zscaler agents. And they did a pretty good job. Every software that's on the market, they better, be wary. And what functional, IT, development shops are doing is that like, we're tired of having to have a separate entity. Like this has been going on for 20 years.
Exactly.
So those days are over.
Yeah.
There's a lot more factoring in security and design and faster. And we're seeing it on the services side where we're able to integrate. And I think other players as well, but I think it's a new dawn where AI can allow some level of, building out security and design prescriptive, recommendations earlier on.
Yeah.
I do think, something like this as a framework is extremely helpful, but it's just, I think testing then becomes more validation and assurance. It's not like the same definition of testing like 10 years ago.
Yeah, because you're not finding a flaw in software the way you were 10 years ago.
Right.
Yeah, interesting. Yeah, go ahead.
I wanted to clarify something I said as well. When I talk about design and saying like it should be able to do this and not this, the not this, you can't quantify everything. So it's like it's implicit.
Yeah.
So one of the conversations we're having right now is like what makes a good user story and conversation between like product and QA and things like that. Where can we improve there in that feedback cycle? Because my job is to help the business say, yes, I don't want to be the no guy. I don't want to slow them down. I want to help them to reduce errors, reduce waste to be more efficient.
Yeah.
So if product design, this product for us, says we need to be able to do this, the implicit is it should do this and only this.
Yeah.
If it does anything else, that's not a feature, that's a bug.
Yeah.
So if that goes to development and development says, oh, I can't do it because of this, and they don't bring that product and work to solve it. Hey, we have a constraint because of limitations on this API or these security concerns or whatever. Well, then if they just try to push it through and work around that and it does something it's not expected to do, it goes to QA. Well, now QA is going to be looking at that ticket and they're going to say, oh, it does things it's not supposed to do.
Yeah.
Well, now you're paying for it because you've got increased development effort because you didn't, shift left the feasibility piece.
Yeah. And I think that's a great point. And the tricky part for me is making that implicit requirement explicit, right? So that it's not implicit, it's explicit that it should only do the things that you've.
Right. Well, and my argument is that it should be implicit, but the way that you do that is when product goes to QA and is like, has that relationship of make sure it only does this. Yeah. If it does anything else, you let me know.
Yeah.
And that's only part of it. I mean, you're always going to have mistakes, but that's a part of how we address those issues.
Yeah. Agreed. Awesome. Anything else?
Nothing online.
Okay. Okay, 2 slides about how Wallarm can help or what Wallarm does. As I said, Wallarm is an API security company. We basically address 3 API security challenges or API security initiatives. The first is a lack of API security posture management. If you like posture management as a term, you can use it. Otherwise, you can say API discovery or API inventory. The whole point there is that you don't know what you don't have, and we want to help you figure that out, create an inventory of the APIs and the risks that they present. One of the things that we do there is we identify sensitive data that's being used in those APIs. So we'll tell you where PII or other types of sensitive data exist in the API endpoints that you have. No judgment on whether it should be there or not, but you get the opportunity to make decisions about, oh yeah, should this API endpoint, it's an authentication endpoint, it should actually have a username and password in it, or it's not an authentication endpoint, why does it have a username and password in the parameters, that kind of thing. So exposing not just the inventory, but the risks there as well. The second piece is that API runtime security or detection and blocking of attacks. The core of what we do is analyzing API traffic, parsing that traffic in order to identify attacks and then block those attacks. We can block stateless attacks like SQL injection, remote code execution, that kind of thing. We also analyze API sessions to look for behavioral anomalies that indicate an attack as well. And we do that with some machine learning algorithms that are kind of cool. And so that blocking is an important component of the product. And then I always talk a little bit about lack of resources, and we address that in 2 ways. The first is building a product that connects to the other tools that you use in your environment to get work done. I will never say that our tools will solve all of the problems for you. You have lots of tools today that you use already. We want to connect to them in ways that are useful. And then the second way is with what we would call co-managed service. So if you don't want to manage the tool yourself, we'll manage it for you. We're not going to manage all of your tools. We don't want to manage your firewalls, but we'll manage your API security. And the second slide is just the architecture, if you will, which is basically a list of the things that we do or the features that we have. So API blocking of attacks, discovery and posture management. That API abuse is the session-based or behavior-based detection. We also have a feature that will look at either web assets themselves or public GitHub and public Postman collections, GitHub repositories and Postman collections, for sensitive data associated with your domain, API data. So essentially that example you had of somebody publishes a token in a GitHub repository, if that GitHub repository is public and we can associate that token to a domain you told us about, we'll say, hey, we found this, maybe you should do something about it. It's kind of a cool feature. And then our perspective is that AI security and API security are tightly coupled, if not a almost entirely overlapping Venn diagram. So we do AI protection as well, looking for things like prompt injection, API abuse by analyzing prompts that pass by us in API traffic. We do have some API security testing capabilities based on either replaying attacks that we've seen in production or based on an API schema. We'll build tests from that. And the attack surface discovery is an external scanning perspective of your environment. And then we do offer a true full SaaS deployment. If you want us to deploy and manage the traffic analysis nodes, you can just redirect traffic to them, or you can deploy them yourself as well. And that's the high level for Wallarm. If you want to dive into more about how Wallarm specifically addresses the OWASP API, the OWASP Business Logic Abuse Top 10, there's a white paper we produced that details that. You're welcome to reach out and grab it. Other than that, I am happy to answer questions about Wallarm, but I won't spend more time on slides on it. And hopefully that was interesting for everyone. I really appreciate everybody's interaction. It's much more fun for me if people participate in their comments and conversation as well. So thank you all for the time.
Thank you.
So I guess in talking about making it explicit, you're saying like, these are the things you might have not even thought to check for.
No, I'm saying that somewhere in the requirements that the developers are reading, it should say something like, this is what the thing you're building should do. It should not do anything else, and anything else it does is considered a defect. I don't think it's important to list out what all those things are, but maybe it is important to have some examples, or that's maybe more the education than the requirement.
That's kind of how I think about it, because it becomes redundant at a point. One of the things we did in the military is like, we had these concepts of like brief by exception and things where you like try to be more efficient and how you communicate, but it was a cultural understanding that this. We didn't say.
I like that term.
And so, like, for me, when I see this, one of the ways that I go about getting buy-in for security in organizations throughout my career, which my current one's company's very proactive about it, but you've had places in the past where it's like security is almost a bad word, is I just put things in other terms. So I'll never say the word security. I'll say confidentiality, I'll say integrity, I'll say availability, but I won't say security. And when I see something like this, I say, oh, this is all quality assurance. So these are the conversations I'm going to have with QA and with product. And we're not going to talk about security, but we're going to talk about, you know.
I like that approach, actually. I like the term cultural understanding, that you're trying to develop a cultural understanding. I think that makes sense. One of the examples I like to give with APIs in particular is, you know, if you have a requirement, you know, let's say I have a database full of data, I need to get access to that data with an API. My requirement is give me these 3 pieces of data. The developer is going to write an API that gets those 3 pieces of data. A smart developer is going to say, well, you know what, next week they're going to ask me for the other 5 pieces of data in there. I'm just going to build the API that way because then I don't have to do it again. I just won't tell anybody, or I won't document it, or whatever it is, right? And then you've got the situation where you're spitting out data. Or another smart developer would say, well, listen, I'm just going to write it so we'll pull whatever data is in that table. And then a month later, somebody adds new data to that table that's not supposed to be shared, and now it's being shared. So those kinds of situations, you know, result in, you know, data disclosure. And then it's not, you know, the developer's trying to be efficient, but it, you know, creates challenging